Hi, welcome to another episode of PX and the Art of Programming. If you are new to this series, I would strongly advise you to listen to the older episodes first before you dive into this one, because I will assume that you are already familiar with some aspects of PX and the way to write perfect, absolutely trustable code. Infallible. Today, I will go further into the concept of functions, and maybe I will touch upon some things on fields. But first, we will start with functions and the implementation, the software implementation of the functions. Because in PX, as I have explained, any program is in itself a programming language. But in the case of PX, which is meant to become a programming language to build any information system, we want to have our own expression interpreter, because we will define our own way of how expressions must look. Right, here in the background, I am running Xcode, and Xcode is running PX at level 4. Level 4 it is running, and on level 4 we have access to the console. And here I have a terminal on the same machine. And this is how I get access to the console at port number 2161. And now I will type an expression. Oh, sorry. 4 plus 9. And that equals 13. This is all the console does. It interprets an expression and gives the result. That's it. This is not an expression, because Perry is not found as an identifier. This is also not an expression. 1a, it's invalid identifier. This also doesn't work. But this works. Len Perry. That's 5. And this also works. Hash d, meaning what is the current date. That's about... Oh, and we also have this function running. Concatenation. And that's about it. Well, we have this function also. It's a selector. Select. Oh, sorry. Blah, blah. We will create an error. And there the software will complain about the fact that the parameter which will define the primary key, and it's blah blah, it wasn't found. But the function s works. But the function s has a parameter, it's called primary key. So, oh, sorry, here. Right. Let's have a look at functions on the inside. For this we go to level 2, but they are defined over there. And here px2 function. This is the header file. This one does the implementation of some function as an example. More functions will follow. This is the implementation of the function #d, and this is the implementation of the function len. This is the implementation of the function concatenate. And this is the implementation of the function select, the one that I was trying to use just now. Select the table blah blah, and this table does not exist. Let's have a look at the implementation of, for instance, the function #d. #d has a constructor. Oh, sorry, this is not okay. I was here. #d has a constructor that is empty. The only thing that during the construction is done is that the name of the function is passed to the constructor of px2 function, but the implementation is empty. This one is defined inline, and it tells something to the system about the return type of this function. And the return type in px can be either a number called micro. If you want to know more about micros, there is a separate episode on micros. And the other possibility is that it is a text. For instance, the function concatenate over here has as data type text. But #d is a number. The date is a number. And then we will look at the function value micro get. And it is implemented, over here. Function #d, function value micro get with the address of a micro, the identifier in case, more about that later, and then the context. These two are not of any issue for this function value method, but others might use these two variables, these two parameters, I should say. First of all, the debugging code. The first thing we check is that the pointer to the micro is valid. px OK micro pointer, px OK m. And this will see to it that the result is a valid pointer and that the content of the result is empty. So you can't call this function with a micro, with the address of a micro, which already has a value. Then it will fail. Under debug, of course. The expression must be valid, must be a valid object. And the expression has a function connected to it, and that function must be equal to this one. I will tell a bit more about the expression identifier later on. Store this in your mind. Well, the function #d, what does it do? Well, it declares a structure my date time, and by default this will be filled with the current day, and then it will will call this object with it will call of this object the method dateGet into the numeric value declared here. And a px_n is a variable of type pxn. We will look it up. Oh, sorry. Get my hands straight on the keyboard. Here you can see it. px_n meaning the variable n of type pxn. And pxn is defined as an unsigned integer 64 bits. Huh? Should be wide enough for a date. Just kidding. And then the micro is initialized with this value, the value of n. This is how hashd works. Well, let me look what will happen if I type in hashd and then enter, and therefore we will set a breakpoint. And the breakpoint, in the console, of course. In the console, this is the statement that sends the prompt, px. Then it will receive some data. And then it will check whether the syntax is okay. And if the syntax is okay, then we will arrive here and we do the evaluation. Agree? If I hit enter, then we are here. Expression, value, text, get. What is the textual value of this expression at this moment in this context? This is not what I meant. I did not break where I wanted it. I wonder why. Bear with me. If I modified the code, maybe I did. hashd. This is our break. Maybe I added a line of code. Well, doesn't matter. We will break this one and start it up again. I want to have my breakpoints in the right order. We're in again. hashd. Yes, breakpoints there. We are here. Step into the code. Yes. Now it's okay. Expression value text get. Now what happens is first we check that the result is empty. This is a string defined on level 2. The string should be empty and the context should be a valid object. Well, if the expression, and every expression is a linked list, a hierarchy of linked lists, and if there is nothing in the list, then there is no expression. But there is one in this case. Now, if there is an expression, then the item count of the linked list of this expression should be 1, because every expression is compiled in such a way. Make some example. If this expression is evaluated, it is, you can call it compiled to this structure. There's the expression 1 times 3 is compiled to the operand multiply, and the operand multiply has 2 subs. Huh? And if it's done like this, plus 5, then it's operand plus, then the operand times 1, 3, and 5. You get the principle? Huh? So an expression has 1 sub after compilation. Back to Xcode. Now, under debug, it is checked that the linked list has only 1 item. Make this a bit larger. And then we get the first item. My first is here inside. And there it shows in the debugger that my first item of the expression is an expression with an identifier. And the identifier is an expression with a pointer to a function, and the function points to px2 func #d. And that is the one that we have just watched. Huh? Well, then we will ask this expression, the first expression, for the textual value. Step into it. And that is the textual value of an expression of type identifier. Now, again, it is checked that the result is an empty string, the context is valid, and that its function is a valid object. An identifier might be negative, and this is for now named to do, something I have to think about. And what we do is we ask the function to come up with the textual value for this expression with the context. And here's the result. We step into the result. Sorry. Yep. We step into function value add, function value text get, of this function. And this function is of type px2 function #d. This is where it's totally okay. This is the textual representation. We looked at because this function #d has only implemented func value micro get. And now we are calling func value text get. But it doesn't matter. It is again checked that the result is empty, that the expression is a valid object, that the context is a valid object. And if the function's data type is of expression type macro, function #d is of type macro, then we declare a micro, and we will ask for the function value of type micro. And this is the function that we have looked at just yet. Now the result, let me have a look. It's microdata. The result is totally empty. It's integers, 0, fraction is 0, -0, and so weiter. And if we initialize it with the value n, 2019, August the 6th, then we look at the result. And here in the integer part of the micro, 2019, August the 6th. Now we have the value of the date in the micro, and then we can add the micro to the result, and the result is an empty string. Here we can see that the string is empty, has a length of 0. And now it has a length, oh, one more step. Now it has a length of 8. And the content of the string is a pointer, ignore px underscore. It's px has a built-in electric fence structure for all the strings. So every string has some leading characters, meaning pix underscore, and some trailing characters. So if for some reason software writes beyond its limits and should write into the data of another string, then chances are quite good that such an illegal operation will be detected. A lot of info in one time. Well, we are in principle we are done. This expression identifier is ready with the getting of the textual results. But as a last step, it will register the result to the context. The context evaluation register for this expression. The reason for this is that the context stores the evaluation info, and in a later stage we will do caching. Well, in this specific case is the function hashd is a function that is very fast. To get today's date won't take any time. But you can imagine that you have functions which are very, very complicated and will take a lot of time. And within a context, since the outcome of a function does not change if the context doesn't change, then there is no need to evaluate the same function twice. You get it? If the context doesn't change and you want to know the value of a certain function for the second time, then the system should come up with the cached version of the last result. So therefore, all the results are registered to the context. And in a later stage, I will build up a cache. And for now, we'll step into it. If there was, you can register an error also, but it's not in this case. And if there was already an error, or if the context evaluation info is on, and there is no error, 0, but the context evaluation info is switched to on by this macro. And therefore, the outcome, the result, is stored. Well, then if the context contained an error, then we can quit. But if there wasn't any error, then we will update the cache. And at this moment, this is just an empty hook. Nothing happens. Just some debugging code, and that's all. Right. And here is no context error. All right. My output has some length. And now it will send the output. And go to the start of the loop, and it will send again the prompt. So, this is the outcome. hashd and the current date. This is a simple function of for the hashd, for the current day. Now let's look at a more complicated function. And that is this one, the length. How does this one work? Well, the length has, the function len has a parameter, and the parameter contains some text. So what the function value micro of a len is a numerical value. The micro value thereof is the length of the first parameter. Now, the first parameter of a function with a parameter, you go back to OpenOffice. Suppose this is the function. Then this is compiled to so this one meaning a group, and this one meaning the only member of the group. If you have a function like concatenation, then this is compiled to the group, and then 1, 2, 3. So a function, this is the expression with the function, then this is the expression telling the system that there is a group, and this is the actual parameter. So if we want to determine, to see the result of the function len, then we have to have the first expression of the first expression. This is the first expression of the expression we are concerned about, and this is the first expression of the first expression. Am I clear? So we can have a look at the debugging code. First of all, we check that the result is a valid micropointer. Then we check that the expression is a valid object. Then we check that the expression, its expression function is equal to this one. And then we check that the first expression of this expression is a valid object. And that the type of the first expression, that's the expression first, its type is equal to expression type group. It should be a group. And then the first expression of the first expression should be a valid object. You can never have enough debugging code. Then what will happen? So during live, these statements are skipped, of course. Now, we declare a local variable holding my text. Then we will ask the first of the first expression to get the text value into my text within this context. And when we have received that text, then we will take the length of this variable, my text dot its len, and this is the value that we store in the result. Let me put a breakpoint here. We'll step to this function also. Len. Oh, sorry. Yep. Let me put a breakpoint here. We're here. The function len, and it is asked to come up with the value as a micro. The first expression, and of the first expression, get the textual value. Well, my text, we can look into my text, and there it says Perry. You get? And my text has a length, and the length is 5. No? Oh. Continue. If not, my output is length. Continue. Now we will send the output. And here we can see a length of 5. Now let's make it a bit more complicated. This is my email address. But I can also write as an expression this. And this is considered to be an expression within an expression, within a string. And now I can ask for len. And then the len will be 14. And this is not the length of this string, but it's the length of this string. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. While this is longer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In this way, the functions work. And now we'll go a step further and have a look at parameters. And I'm working on parameters at the moment. It's not quite done yet. But I want to work with named parameters. This function, the function select, is to come up with data like the select statement in SQL. Select star from table name where la 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 la. The same idea. I have named this function simply S. And for now, it has only one parameter. And this parameter is called the primary key. FLD meaning field, PK meaning primary key. A primary key is a column of a table that holds a unique, non-changeable, meaningless number, by definition. Just that you know it. And we need the primary key as the info for the table. So in PX we do not work with the concept of tables and fields, but we work only with the concept of fields with a subclass of fields called primary key. A primary key is equal in its idea to a table. Quite a... Well, what I think I'm very proud of this way, it's not an invention or so, but it's a way to look at data definition. So you don't use the concept table, you have a primary key and other keys, other fields, some of them secondary keys, some data fields, whatever. But they're all fields. So there's no need for a concept of table in the language within PX. And furthermore, fields are implemented. No, not here. I cannot show it here. I have to show it over fields here. Fields are a kind of function. Because there is no intrinsic difference between a field or a function. It's a matter of context. Let me explain. If I have an expression with some errors in it. Sorry. This expression has an error because 10 minus 10 equals 0 and you can't divide by 0. Then the software will come up with this output. And as you can see, this is a table. It needs to be a table. 10 minus 10 equals 0. 10 minus 10 in between parentheses is a 0. 3 divided by the outcome of 10 minus 10 is a division by 0, is wrong. 2 divided by 3 divided by... it has an answer, but it's still an error. Sorry, still an error. What happened here? Still an error. And this is also still an error. But this is a table. You get? And now let's do something funny. Let's ask for this table. If something goes wrong, what is it? Yeah, this is what I meant. Again. This is the expression that I was looking for. Select the content of the evaluation info. Well, at this moment that I run this statement, then the evaluation info is empty. But now let's do something different. Man, it's going to be funny. Oh, breakpoint. I'm sorry. Yeah, I'm sorry. I have to show it another time. Okay. But it will work in the future. And for now, I will have a look at this one. I defined a small table within px with the list of all the defined passwords in their encrypted form. And at this moment, it only contains one password, the root password. And the encrypted data is not even all of the data, the first 80 characters of the encrypted password. But here you can see the primary key of the password, just one. The code of the password, root. And here's the encrypted data. So this is how this works. It's a function S, and the parameter is the password primary key. It's not a table that I haven't defined this table for any other reason than just for testing at level 2. But let me have a look at the table definition, the primary key definition. It's done here. This is the declaration of the field primary key password. And this is the data get function, which will return all the data that there is. And what it does, it looks up the content of, wait a second, it's all about this file. There's px2expr.txt. It contains a list of all the passwords that you have defined. This is the code of the password. Here's the character tab. Show tabs. Oh. Why don't I see the tab? There is a tab. Oh. Anyway, maybe some bug in Text Wrangler. A root tab and then the encryption data. Well, this is the file that I read in during startup, and it's placed in this parameter, this field of G2, and G2 is the singleton. I will make a different episode solely on the singleton G, but it has a field called its passwords. Multiple passwords are possible, and it steps through all the lines, and it creates a first column with a primary key, a nonsensical, a meaningless number, then the code of the password, then the actual encrypted data, and of the encrypted data only the first 80 characters, and then a new line character. That's all that this primary key does. In the future, primary keys will get data from the SQL server, for instance. Or in the case of views, where if you want to define a subset of data, then the view will get its data from some kind of process. Maybe you will merge data from table A with data from table B and table C and put it all together, and that will be your primary key data. Now, the last thing that I will tell you about expressions when discussing expressions is to set up the way of programming, how to do it. And for this, we return to the test code. I have made a separate episode on test code. And this is the testing code of all the expressions. It's quite a file. We are now at line number 1922. And this is all the testing code of the function select. Here you can see that this expression, select with an empty parameter, it will compile okay for the moment. But if you ask for the evaluation, you get the textual. If you ask for the textual value, then you will get an error. px okay always my expression context dot context error. It should be true. And if you get the evaluation info, then it will contain strings like error, and this will be in the string, and this will be in the string, and that. No value. All kinds of errors. I've been programming on this today. And I ended here with a valid call of the function s, with a valid name of a primary key. Then I ask for the expression value text, get into my results, and my results should contain this is the header. This piece is the first line, equal to what you see here. That should be in the output. And then root should be in the output, and px.encryption should be in the output. This is where I left off before I started this episode. Now I will remove this piece of temporary code and continue with programming. And if I run my test now, and this is the way to program in PX. So first you write, in this case, an expression, but I want this expression to be valid, namely a call of the function s, and then the parameter px2expr database, pk that should be, SQL DB primary key, that should be the one, equal to the one here above. Oh, password. Oh, yeah, password, that's the one, sorry. This is the expression I want to be valid, but now I have named this parameter with the parameter name primary key. And the goal is that this will be a valid call. Also select primary key px passwords, and then a second parameter format HTML. And then things will get interesting and more interesting. And with named parameters, then we can also change the order of the parameters, because every parameter is named. Then this will be a valid expression also. Well, if I now run this code, let me first quit PX in a normal way. It has a bit of a trouble to let me quit. Oh well. The console isn't quitting quite so nice as I wanted. Right, but the cleanup went okay. So now I will start up the test code. Run test at startup. Value 1. I will switch back to level 2. That's the level enough for testing. And now it should hop into, yep. Here something goes. Yeah, here it says that the syntax is not okay. And my expression, let me have a look. It says the error, syntax error in members of group at, and the location of the error, parenthesis left, pk, and there is the group with the error. The reason for this is that I haven't worked on named parameters yet. So, but now I can work on the naming of parameters. And then I will work on it just as long as just to make sure that this test code will work. Dus first you write test code and then you start implementing the actual software, not the other way around. Because in that order of things, it might be, you might be tempted to skip to write the test code. because the actual software is running, and you might wonder, argue, say to yourself, well, just don't mind about the test code. It's working, isn't it? But therefore, it's good practice to first write the testing code and then to write the implementation. Well, thank you very much. I'm going to get on with my project and go for this, the named parameter stuff on functions. And hope that you will listen to a next episode on expressions, functions and fields. Thank you very much for listening.